Please support me through PayPal to devinwyndham@gmail.com. I also do tutoring. I'm based in Fairfax, Virginia. I do tutoring both online and in person. If you're interested in tutoring, I can be reached at the same email. Alright, today we're going to do the second part of my proof that the area of a circle is pi r squared. Here we can see the proof of the first part of my proof. Notice I used an inscribed polygon, although I'm still feeling a little bit uneasy about it because even if this polygon's sides increase to infinity, they're straight sides, so how do I know that its limit is the circle? So I'd feel more comfortable if we do a circumscribed polygon, which I'm doing here. This is the second part of my proof. So the area of this polygon is 2n. Well, first of all, how did I broke it? First, let's do the, all right. I broke up the polygon into triangles. And then, why did I break the triangle in half again? Because the original triangle, like these sides, what are they? I know this height is r, and if I divide the triangle in half, I can get b and maybe use a tangent, just like, you know, I used a sign here. That's what motivated breaking it in half. How many of these half triangles do I have? 2n, right? If the number of sides of the polygon is n. So the area of the polygon, big A, is equal to 2n times the area of this triangle, which is half the base times the height. The 2's cancel, but in math, basically, but just means we're saying another sentence, another statement. But the tangent of theta is equal to b over r. And, you know, I said the reason I divided this in two was to get, you know, use the tangent. So there I am using the tangent. And so, you know, so let's go back to this, the area equals NBR, and then to use our tangent, notice that b is equal to r tan theta, so we can plug that in. Or the r's multiply, and so we get r squared, and this theta is equal to 2 pi over 2n. Right, because there are 2n of these thetas. We're dealing with radians, which is equal to nr squared times the tangent of pi over n. The 2's cancel. Now, to motivate this step from here to here, I thought back to my first proof, because I'm like, what can I do with this? Because tangent of pi over n is going to 0. This is going to infinity. That's undetermined. Infinity times 0 is like, I don't know what that is. But notice here, the trick I had this sine theta, but I was able to use this, the limit as theta approaches 0 of sine theta over theta is 1. So if I can do a trick like that, notice what's happening is the argument of the trigonometric function appears in the denominator here. So I want to make that show up here. That's why I put its argument in the denominator and then multiply by that denominator, so I'm harmless. I'm not harming this expression. All right. See, everything else is the same. All I did is add these pi over n's, right? That's all I did. Okay. Now here, because we have this really neat limit, that the limit as theta approaches 0 of sine theta over theta is 1, I'm going to tease out a sign. That's what I do here. So I have my... Is that what I did? Well, let's start with the obvious. So yeah, I teased out a sign. I rewrote tangent of pi over n as sine of pi over n or cosine pi over n. This denominator got copied. These n's canceled, right? What's happening here? Oh, so I'm taking the cosine pi over n out of these parentheses, and it's coming down there. That's all that's happening. And then this whole expression is approaching pi r squared. Cosine pi over n is approaching, because we know that the limit as theta approaches 0 of cosine theta is equal to 1. And here again, we're using the fact that the limit as theta approaches 0 of sine theta over theta is 1. So I did this proof because we all learn that the area of a circle is pi r squared, but it's never proved to us. And I think understanding is more important in math than memorizing. And when I mean understanding, I mean proving everything to yourself, or convincing yourself that everything that you learn in math is true, insofar as possible. So now, I think we understand why the area of a circle is pi r squared. All right. Bye for now.